Hello, in today's lesson, our learning target is I can model real world scenarios mathematically using linear functions. The past couple days, weeks, we've been doing a lot of really good work on learning about functions and linear functions and equations and inequalities. And now we're going to use all the knowledge we've gained and apply it to modeling real world scenarios, which is hopefully more exciting than lots of stuff we do in kind of the theoretical realm of math. The first thing there are many ways to go about modeling real world scenarios and solving real world problems. So my approach is just one of many. So I'd encourage you to experiment with your own methods or think of things in different ways. But what I'm going to present here is how I like to solve these problems. In linear word problems, you're going to be given some situation, and you're going to have some data or numbers. And the next step, so usually what I like to do first is write down the important info. So I'll write that down, or circle it if you're working on a worksheet. Then I really like to find a way to put it into slope-intercept form. So y equals mx plus b form. And I find once I can get the problem modeled in this form, it's pretty straightforward to either solve the problem or graph it. So one important thing is slope-intercept form, we know, has two variables, the slope and the y-intercept. But in word problems, all of these components have a bit of a different meaning. So y is always going to be our dependent variable. So y is going to depend upon x, which x would be our independent variable. So I'll write that down. Well, meanwhile, m, our slope, will be our rate, or rate, we could write rate of change in parentheses. And b would be our initial or starting value. So I think the easiest way to kind of explore this is to start with a basic example. So suppose we have Jim. Jim starts the summer with $200. He makes $50 each day mowing lawns. So, how much money will he have after 7 days? How long will it take for him to make $1,000? So this is a very common linear word problem. You'll have someone who makes money, they make a certain amount of money each day, week, month, year, and we want to have an equation so that we can plug in any number of days and see how much money they have. So it's time to start identifying what our quantities are. So first let's look at our variables. So our two variables are going to be the amount of money he has, so how much money he has, and the time, or days. So we want to see which depends on which. So does the day depend on how much money he has? I don't think so, because time's just kind of going to keep on going. Time is generally going to be our independent variable. So in this case, our independent variable is time, which more specifically would be in days in this example. So our dependent variable, what depends upon time, is how much money he makes. So that's independent variable, and this is our dependent variable. So again, the amount of money depends on how many days he works. Like, if he works like 1 or 2 days, he's not going to have that much money. But if he works lots of days, he's going to make a lot of money, might even get rich. So we identified our variables. So in our equation, we can either just use y or x, or in real world situations, it's helpful to use function notation and use letters that kind of denote the different quantities. So I would say m of d is our dependent variable, and m is going to stand for money, and d is going to stand for days. So I'm going to write money is equal to m, days is d. So, and we know that our independent variable is going to be the number of days. So now we want to know what our rate is. So our rate is going to be how much money he makes each day. So he's going to make $50 each day, and that is going to be our rate. So the rate is $50, because that's what's changing, is how much money he makes each day. And the last thing, so our rate is going to go in front of the d. And the last thing we want to find is our initial value. For the initial value, you want to look for words like starts, begins, sometimes even the word initial. So our initial value is going to be that $200. So, all right, plus 200 here, and now we have our model. So we are asked how much money will he have after 7 days. So we got the hard part over with. The hard part is interpreting what's in here and putting it into numbers and equations. So how much money will he make after 7 days? To do that, we'll plug in 7 for the number of days, and we'll get 50 times 7 plus 200, which is equal to 350 plus 200, which is equal to $550. So that's our answer to that question. Then we're asked how long will it take him to make $1,000. So in that case, we're looking for the number of days, and we already know the amount of money. So in that case, we plug in 1,000 over here, and we'd say 1,000 is equal to 50d plus 200, and we just solve for d. So I'd subtract 200 from each side. We get 800 is equal to 50d. Then we could divide each side by 50. Those will cancel. 80 divided by 5 is going to be equal to 160. So we get 160 days. Or not 160, 16, sorry. All our friend Jim has to do is work 16 days, and he'll make $1,000. So now, suppose we wanted to graph this this function. So that's often something that you'll be asked to do. So I'm just going to move this a little bit over to the side. So there we go. And I'll write in case it's off the screen, I'll write down our function again. M of d is equal to 50d plus 200. So in making a graph, first we want to think about what's relevant. So we don't care about the negative number of days, right? Because that doesn't make sense. So it makes sense to really emphasize the first quadrant in our graph, because we don't really care about what's going on down here, and we know that he's not going to have negative money. He's not losing any money. So we always will put our dependent variable on the y-axis and our independent variable on the x-axis, and it's nice to label what they stand for. So here we'll have money. So, and then we want to make a scale. So our scale is we can make little ticks, and we can have each tick maybe represent $50, since that's the amount of money you were interested in. So that would be 300, 400, 500, 600, 700, 800, 900, 1,000, and then we keep going. And our days, we can just do it by one day. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then once we have our scale set up, we'd graph it just like any equation. So our initial value, or y-intercept, is going to be equal to 200. So we know that point. And we know we have 2 points there. We can also just say we know that each day he makes $50. So after one day, we'll have $250. So we'll have that point. After 2 days, we'd have $300, etc. And then we could just connect the dots with a line. And I know this graph isn't perfect because I didn't use a ruler, but we can kind of check. We said in 16 days he'll make $1,000. So if we go up 16 and then go to the left, see, I guess I actually did do a pretty good job. After 16 days, he will have $1,000. So often you'll be asked to make a graph in word problems, and even if you're not, it can help to understand the situation and kind of put some perspective behind it. So remember, when making graphs, it's really important to set an appropriate scale and clearly mark what your variables are, and kind of emphasize what's important. Because it's a lot nicer to us to have this nice graph that fills up the whole screen than if we just had something that looked like this and we'd have all this blank space that we're not really using. So those are just some tips on making good graphs. So that's going to conclude our lesson for today. There's a lot of nuance to word problems, so I want to do more examples. So in our next lesson, we're going to do a couple more examples of these linear word problems. So stay tuned for that.